All right, what I need you to do, grab a piece of graph paper, on your graph paper, you're going to, so you got a piece of graph paper, on that piece of graph paper, you're gonna put it up and down, just like you would a normal piece of paper. You're gonna draw the x-axis on it right in the middle somewhere, pretty close to the middle, doesn't have to be exactly in the middle. You're gonna draw the y-axis on it, somewhere close right in the middle. Then I want you to graph these 3 points. Once you graph them, I want you to label them. Point A, -12.4, put the label it with the letter and label it with the numbers. Remember that the first number, like the -12 right there, that tells you how much to move left or right from the origin, from the center. The second number tells you how much to move up or down. So first number left or right, second number up or down. So go ahead and take a minute and do that. So we go to graph this. Drawing your x-axis, you're drawing your y-axis. My graph might not look the greatest. Just go with it. X-axis, y-axis. We're going to graph A, -12, so left 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up 4, 1, 2, 3, 4. So A is going to be somewhere right about in there. Label it A and -12, comma 4. Then do B, 0, left to right 0, up 1, 2, 3, 4. That's B. 0, 4. C is -6, 10. 1, 2, 3, 4, 5, 6. And then up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ran off my graph there. That's C. And that's -6, 10. I want you to connect them. My lines again might not be too straight. Hopefully yours is a little straighter. So we have that triangle. Now the next thing I want you to do, so I want you to take a second and I want you to find the midpoint of segment AC. So you're finding the midpoint of that side right there. Midpoint of AC. The midpoint formula looks like this. You add the x's from the 2 points and divide by 2. You add the y's of the 2 points and divide by 2. So you're trying to find the midpoint of segment AC. I also want you to find the midpoint of segment BC on this side. So find the midpoint of those 2 sides. You're going to use that. Remember, your first number is your x, your second number is your y in each one. These x's and y's in this formula, they should have little subscripts with them, but we usually just don't write them. So if I'm looking at segment AC, hopefully you sort of figure this out yourself. For AC, your x's are -12 plus a -6 divided by 2, and your y's are 4 plus 10 divided by 2. Then all you're going to do to find the midpoint of AC is you're going to do all that math. -12 plus -6 is -18. -18 divided by 2 is -9. 4 plus 10 is 14. Divided by 2 is 7. That's the midpoint of segment AC. So let's come over here, go back over here to the graph, and let's graph that point. -9, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then up 7. 1, 2, 3, 4, 5, 6, 7. It should, if it doesn't, it should fall on AC right there. And we're going to label that point D. Label that point D. So point D is right there. The coordinates of point D that's right there are -9, 7. That's the midpoint of segment AC. If I connected if I connected D down here to B, then segment BD would be a median. But that's not what we're going to do in this case. That's what we covered before. That's not what we're going to do right now. Next thing you're going to do is you're going to find the midpoint of segment BC. when I find the midpoint of segment BC, I'm going to take the x's from B and C, which is 0 and -6. 0 plus -6, and I'm just going to do this one quickly in my head. 0 plus -6 is -6. -6 divided by 2 is -3. So the x-coordinate of the midpoint of segment BC right here is -3. Then I'm going to do the y-coordinates. 10 plus 4 is 14. 14 divided by 2 is 7. So the midpoint of BC is -3, 7. So I count over 1, 2, 3. Ignore that straight line that just went through there. And I go up 1, 2, 3, 4, 5, 6, 7. And it ends up being right there. And we're going to label that point. We're going to label it point E. Point E. So this is point E. And the coordinates of point E are -3 and 7. -3 and 7. Now the next thing I want you to do, I want you to connect point D to point E. That segment, that's what we're going to talk about today, that's what we're going to discuss today, and that's what you're supposed to learn today. That segment is called a mid-segment of that triangle. It's a mid-segment of the triangle. Don't get it confused with a median. A median connects a vertex to a midpoint. A mid-segment connects a midpoint of one side of a triangle to a midpoint of another side of the triangle. So that's a mid-segment. Now with a mid-segment, there's a mid-segment theorem, and using that mid-segment theorem, what it tells us, and what we can probably tell right here, if we look at segment DE and we look at segment AB, you can probably tell that those two segments are parallel to each other. So that's one of the things that the theorem tells us, is that those two segments must be parallel to each other. The other thing, that's what we're going to do next. The other thing that it tells us is something about their lengths. To find the lengths on a coordinate system like we are here, we could use the distance formula. Subtract the x's, square that answer. Subtract the y's and square that answer. If you don't have those formulas memorized, make sure you're starting to get them. Now, in this case, to do segment DE, we really don't have to use this big long formula, because segment DE is a horizontal segment. Anytime you have a horizontal or a vertical segment, all you really got to do is count to find the length. So if I start at E and I walk over to D, I walk 1, 2, 3, 4, 5, 6 spaces. So the length of that segment DE is 6 units. Now if I go down here to AB, it's also a horizontal segment. And all I got to do is count from B over to A. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the length of that is 12. And what you should figure out there is that the mid-segment that's parallel to the side, or the side of the triangle that's parallel to the mid-segment, those two, the mid-segment length is always going to be half whatever the side of the triangle is. So since this is 6, the side down here must be 12. Got to make sure that you have this formula. Got to make sure that you know that formula, the midpoint formula and the distance formula. All right, take a minute, graph this triangle. And I know this says triangle ABC. It's not supposed to say triangle ABC there. It's supposed to say triangle NTS there. So we're going to graph triangle NTS. 3, -3 is in. Label it with N, T, and S, and label it with the coordinates. So I'm going to graph this, and just looking at it, I see that I have an X that's 12 and I have a Y that's 10. So I need to be more on the positive side. So maybe when you draw this, and on your paper, it's probably not going to make a big difference if you're on a big graph. But on my paper, I need to be able to go to the right 10, and I need to be able to go up 12. So I'm going to put my y-axis over here, and I'm going to put my x-axis like right in there somewhere. Hopefully I have enough space then. So the first one, 3, -3, I go 1, 2, 3, and down 3, 1, 2, 3. That is point N. 3, -3. Then the next one, 5, 10, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right there. That's T. And that's 5, 10. Then I graph the next one's 12, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. And that's S. It's 12, 7. Connect those. That's going to form our triangle. If I can sort of get straight here, get straight here. That wasn't very good. So that's our triangle. Next thing I want you to do, find the midpoint of each of those sides of that triangle. So we're going to find the midpoint of segment ST. And we're going to find the midpoint of segment TN. And we're going to find the midpoint of segment SN. We're going to find the midpoint of all those by using the midpoint formula. Again, remember the midpoint formula, you add the x's, divide by 2, add the y's, divide by 2. So if I'm looking at S and T, that means I'm using this point and I'm using this point. So my x's, 12 and 5. Well, 12 plus 5 is 17. 17 divided by 2 is 8.5. It's all right to have a decimal there. So a lot of times this stuff's not going to come out even. Then I do the y's. The y's are 10 and 7. 10 plus 7 is 17. 17 divided by 2 is 8.5. So that's a midpoint. So if I graph the point 8.5, and we'll call it, we got N, T, and S. We'll call this B. We'll call the next one L, and we'll call the last one here A. If I got that point, 8.5, 8.5, I count over 1, 2, 3, 4, 5, 6, 7, 8, and I go out a half. So right here in the middle of this block, then I go up 8.5. 1, 2, 3, 4, 5, 6, 7, 8 and a half, and that's going to put me somewhere right about there. We're going to call that B, and that's 8.5, comma, 8.5. Next, we're going to find the midpoint of segment TN. So we're using this point, and we're using this point. So my x's are 5 and 3. 5 plus 3 is 8. 8 divided by 2 is 4. The y's, 10 and -3. 10 plus a -3 is 7. 7 divided by 2 is 3.5. And we're going to call that point L. So I count over 1, 2, 3, 4. And then I go up 3.5. 1, 2, 3.5, and I'm going to be somewhere right about in there. So that's point L, and it's 4, comma 3.5. That's that midpoint. If I connect those two, which I'm going to do, I have a mid segment. But I'm going to go ahead and find the, before we deal with the mid segment or anything, we'll go ahead and find the other midpoint. The other midpoint, we're going to use point N and point S. So for S, we got 12 and 3 as our x's, so 12 plus 3 is 15. Divided by 2 is 7.5. Then our y, 7, -3, 7 plus -3 is 4. 4 divided by 2 is 2. We're going to call that point A. So I'm going to go over 1, 2, 3, 4, 5, 6, 7.5 and up 2. 1, 2. So my drawing here is not very good. My thing's crooked. Let me count it again. 1, 2, 3, 4, 5, 6, 7.5 up 1, 2. So the point should actually be right there. It's because my segment's not drawn very well. And that's going to be point A. Point A is 7.5, 2. Now, before I draw any of the other mid-segments, what we're going to do is we're going to find the length of segment BL. So we're actually going to find the length of segment BL, and we're going to find the length of segment NS. We're going to find those two lengths, and the way we're going to do that is by using the distance formula. So to use the distance formula on BL, I'm going to write this one out. The next one I won't write out so much. For B and L, we got to use those two ordered pairs right there. So we're going to do the x's, which is 8.5 minus 4, and we're going to square that. Plus, then we're going to do the y's, which is 8.5 and 3.5. So 8.5 minus 3.5, and we're going to square that answer. Some of this you can do in your head. 8.5 minus 4 is 4.5. So we got 4.5 squared plus 8.5 minus 3.5 is 5. 5 squared. Grab your calculator, do some of the math here. I know that 5 squared is 25. Then 4.5 squared is 20.25. Well, then we're going to add those two together. 20.25 plus 25 gives us the square root of 45.25. I'm going to move this NS down here because I'm too close. And then you just take the square root. So on your calculator, second square root, 45.25, and you end up with segment BL equals 6.727. Round it up. I went out 3 places just so we can, because we're probably not going to be exact, but I want to be fairly close so you can see what should happen when you're looking at a mid-segment in relationship to that side of the triangle that it's parallel to. On the next one, for N and S, so I use this ordered pair and that ordered pair. So for this one, and I'm going to do more of this, I'm not going to write it out as much. So for the x's, I got 12 minus 3. 12 minus 3 is 9. So I got 9 squared plus, for the y's, I got 7 minus a negative 3. You got to be careful here because you got 7 minus a negative 3. Well, then that's going to change to plus. So you got 7 plus 3, which is 10 squared. 9 squared is 81. 10 squared is 100. Add those two together and you get 181. Then you got to find the square root of that. So on your calculator, square root 181, and you end up with NS, the length of that segment ends up being 13.454. Went out 3 places there. So this segment is 6.727. This segment, the side of the triangle from here to there, is 13.454. Well, what should be true about those two is this mid segment should be half as long as that one. So if we take that 6.727 on our calculator and we times it by 2, we should get awful close to that one. And if you take this and multiply it by 2, you get exactly that right there. So mid segment's always half as long. This mid segment's always half as long as the side of the triangle that it's parallel to. Now if I did this and connected this one, then this mid segment should be half the length of that one right there. So instead of doing the distance formula on both these, I could do the distance formula on this one and then just double it to get the length of the side of the triangle, and we should be fairly close. And if I connected these two, it's going to be the same way. This mid segment is going to be half as long as side NT there in the triangle. And that's the way it's going to be on all this. And the other thing, and we're going to talk about this here in a second, that triangle is a special triangle that we just made in there by connecting the mid segments. That's a special triangle. And the perimeter of that triangle should be half the perimeter of the original triangle, the big triangle. All right, these are your notes. Mid segment of a triangle. That's what we're going to talk about. Be able to use the mid segments of triangles and be able to use the mid segment theorem. Be able to do the graphing, all that stuff, and even if you're not on the graph, be able to do it. Mid segment of a triangle is a segment that connects the midpoints of two sides of a triangle. Again, don't get mid segment confused with median. Two completely different things. Mid segment. If I put that midpoint right there on that side of the triangle, I put that midpoint on that side of the triangle, then I connect them. That's called a mid segment. That red segment right there is called a mid segment. And I know that that mid segment is going to be half as long as that side of that triangle. And it's going to be parallel to that side of that triangle. And that's what the theorem is going to tell us. If I do the other midpoint down here on the bottom, I got that midpoint right there. And then I connect it. That's another mid segment for this triangle. If I connect it to there, that's another mid segment. Every triangle is going to have 3 mid segments. When I connect those and I have this triangle in the middle here that connects all the mid segments, that's called the mid segment triangle. And we know that the perimeter of that mid segment triangle is always half whatever the perimeter of the big triangle was. Area doesn't work out that way. Perimeter, this red triangle is half what the black triangle is, or the black triangle is double what the red triangle is as far as perimeter, but area is something different. Doesn't work that way. This is the mid-segment theorem. Segment connecting the midpoints of two sides of a triangle is parallel to and half the length of the third side. So if I look at MP right here, MP is half as long as this side of the triangle, BC down there, and it is parallel to it. So if I told you MP was, if I told you MP was 5 units long, whatever, then BC down here would have to be 10 units long. These should have symbols above them here. Forgot them. So MP is always parallel to BC. MN is parallel to segment AC. Segment NP is parallel to segment BA. These don't need symbols because you're dealing with links over here. 1/2 of whatever BC is, so BC is 10. 1/2 times 10 should give you how long MP right there is, and it would end up being 5, like we said. MN, this segment, that mid segment, should be half as long as segment AC or side AC of that triangle. And it's going to be parallel. Those two are going to be parallel to each other. And it works the same for NP. NP is half as long as AB, and AB is parallel to segment NP. That's your assignment. Page 333, 1, 3, 4, 7 through 21, and 25.